Our physics lab experiment is going to demonstrate the effects of how centripetal force acts on an object. We attach strings to a flat piece of hard plastic to make a stable base for a full glass of water in which we will be placing on top. We will conclude that it is possible for the water to stay in place as we rotate the base in a complete circle through the air. Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. Our demonstration is an example of centripetal force and circular motion. The water and the cup are both being pulled by the force of gravity to move downwards, but are redirected into a circular path by the centripetal force of the rope. Because of this, the water stays neatly in the cup and does not fall on his head. This is the same effect you feel when you go around a tight corner in the car and get squished against the door. As you can see, the cup is spinning in a complete circle and the water stays in place even when it is completely upside down. A real-life example of centripetal force is going on a loop on a roller coaster. Ever wonder why we don't fall off the ride while we're upside down? Not only does the seatbelt help, but also the centripetal force. The ride applies the centripetal force to keep us moving along with the ride instead of falling straight down with gravity. Here's the equation for centripetal force. It's mass times velocity squared over the radius. We are going to show how all three of these factors affect the force. As mass increases, so does centripetal force. Likewise, as mass decreases, centripetal force also decreases. Here we are showing that if we increase the mass by a factor of 1, the force also increases by a factor of 1, showing that the force and mass are directly proportional. As velocity increases, centripetal force also increases. Likewise, as velocity decreases, centripetal force also decreases. Here we are showing that if we increase the velocity from 1 to 2, then the force equals the velocity squared, making it 4. If the radius is increased, then the centripetal force is decreased. And if the radius is decreased, then the centripetal force is increased. Here we are showing that if the radius is increased, then the centripetal force should be decreased. Here is a sample problem that we created. If the final speed of a stone is 4 times the initial speed, what is the final centripetal force in relation to the initial? So, if the final velocity is 4 times the initial, then the final centripetal force should be 16 times the initial centripetal force. This concludes our lab experiment on centripetal force.